Welcome to the Walton Pi. Today we're going to go through some different functions and practice identifying the domain, the codomain, the range, as well as figuring out if it's piecewise, even, and odd. So we're just going to go through a bunch of different examples of each of these things. Our first function is going to be this one. F of x equals 3x squared plus 7 all over x squared plus 6x plus 5. So the first thing we might want to ask ourselves is what is going to be the domain? So the domain is any x value that is going to give us a valid output. So because we are doing division, this is when the denominator is not equal to 0. So we need to figure out when is that the case. So we need to solve for when is x squared plus 6x plus 5 equal to 0. Now, a nice thing about this polynomial is that it's going to factor, and it factors as x plus 1 times x plus 5. So anytime either of those two pieces are equal to 0, then the denominator will be 0. So that tells us that our domain is going to be x cannot be 1 and x cannot be 5. So one way we could write this is this, or we could write it in interval notation. So going from negative infinity to 1, unioned with from 1 to 5, and then unioned again with 5 to infinity. That is going to be the domain. Now our codomain, this is going to be everything, because we are assuming that it's going to be a function from the real numbers to the real numbers, and we are not restricting the codomain at all. However, so the codomain is going to be R, or in other words, the real numbers. So this is all real numbers. But then if we were to look at, for example, the range though, this is not necessarily equal to the codomain. This is going to be the set of all values that we can get out. Now, something we might notice is this top, this is always positive, but then this bottom, this can actually become negative. And so because of this, it's going to be kind of difficult to figure out what the range and what the range of this function would be without graphing it. So let's come up with a different function that's going to be a little bit easier to classify. So let's just deal with f of x is equal to x squared plus 1. So here, our domain is going to be all real numbers. And the reason for this is because we are not going to have any places where the function would not be defined. Any x value gives a valid output. Our codomain, again, is going to be all real numbers as well. But then our range is going to be a subset of the real numbers. If we were to look at the graph of x squared plus 1, we would see it would look something like this, where it intersects here at 1, but then it goes upwards, but it never goes below that. So that tells us that our range is going to be just the interval starting at 1 and then going up to infinity. That's going to be what our range is. Now, talking about classifying different functions, this function turns out to be able to be classified a little bit more. This is going to be an even function. The reason we can tell this is it's actually symmetric across the vertical axis. If we look at the value of the function here, if we were to go horizontally across, it's the same value on the other side. The reason for that is because f of negative x, that's just going to be negative x all squared plus 1. Well, negative x squared, that's just x squared. And so that gives us the same output as if we were to put in positive x. So this is actually also an even function. So let's look to see if we can come up with an odd function. So let's say that we have we want f of x to be equal to negative f of negative x. Or another way of writing this is that negative f of x is equal to f of negative x. This is going to be our description for an odd function. So an example of an odd function would be f of x is equal to x cubed minus 7x plus 1 over x. This is an odd function. Now, since we're talking about domains, ranges, and codomains, let's just quickly establish that the domain of this function is just x cannot be 0. Add this division, that tells us that the domain can't be 0, because then we would be dividing by a 0. We could go through and figure out what the range and the codomain is going to be all real numbers, but we could figure out the range, but the easiest way to do that would be to graph it and see if there's any y values that it never attains. Now to show that this is going to be an odd function, let's look at f of negative x. Well, that's going to be negative x cubed minus 7 times negative x plus 1 over negative x. So that's negative x cubed plus 7x minus 1 over x, which is negative 1 times x cubed minus 7x plus 1 over x. So that's a negative 1 times f of positive x. So this is going to be an odd function. Let's now look at a piecewise function and figure out how we might be able to graph that. So let's say that f of x is defined piecewise. So f of x is equal to x squared if x is less than or equal to 0, 3 if x is between, so let's put x between 0 less than or equal to x less than or equal to 4, and then negative x if x is bigger than 4. Sorry, because that needs to be strictly less than x, because we're already including 0 somewhere. The reason I had to do that is if I didn't, then what would f of 0 be if we had kept 0 is less than or equal to x? Well, one piece tells us it should be x squared, so that should give us a 0, but then the other piece tells us it needs to be 3. This is giving us 2 outputs for 1 input, which would mean that this would not be a function. And so that is why we needed to remove that part, so it was just strictly less than x. If we were to then look at what would this look like when we were graphing it, well, we know on this side, so over here, when x is less than 0, it's going to just be x squared. So there's our graph of x squared. Yeah, let's actually get rid of that extra bit. There we go. So there is x squared. Then it's equal to 3 from 0 to 4. So 1, 2, 3, 4. 1, 2, 3. Now I'm drawing an open circle as opposed to the closed circle we had at the origin to signify that that is one of the endpoints, but it is not included. That is what this less than right here is telling us. But on the other end, it's going to be a closed circle because it is included. Whoops, how did I do that? There we go. So that's going to be a closed circle because it is a less than or equal to on this side. And then when x is bigger than 4, it's going to be a negative x. So 1, 2, 3, 4. It's going to be here and then continue that way. So that would be how we graph this piecewise function. Now, if we were to go through and figure out what's the domain of this function, well, this is going to be all real numbers, so negative infinity all the way up to infinity, because it's defined for every x value. The codomain is again going to be all real numbers. So the codomain is not often a very useful or well, it is useful, but it's not often a very interesting thing to look at. The more interesting one is often the range. So to look at the range, we need to figure out what are all the x values we can get. Well, from this x squared, we are getting 0 all the way up, but then we get a whole bunch of extra 3's, but that doesn't impact the range at all. We know we hit 3 at least once, and that's all we care about. But then we also are going to get everything below -4. So the range is going to be -infinity to -4, unioned with 0 to infinity. Now, remember that these square brackets say we include that number, and then these parentheses mean we don't include it. I hope you enjoyed this video and that it was helpful in clarifying some concepts involving functions. Please check out some of my other videos, and please like and subscribe, as it will help me out to be able to continue to make these sorts of videos to help different people with different math concepts. I hope you all have a great day and good luck with the rest of your math.